We are the team number 4, and in this case, we decided to do an optimization problem based on a construction company that hired its employees for a fixed schedule and but loses money by paying them for the hours that their employees do not carry out any activity. With this problem, we will be able to know how many hours employees have to be hired and also what activities they will carry out, thus minimizing the cost of having them present and also preventing them from being paid for their hours. The types of problems can be found all types of companies and can even work in maximizing productivity by changing some restrictions. Our team is confirmed by Giancarlo Jackson Estrada Martinez, Alejandro Martínez Sánchez, Melanie Judith García Revillas y Sebastián Mayor.
Decision variables. XI total hours by worker employer A, XIJ hours that employer I worked on the activity J, HJ hours that are already having working in the activity J, max high the maximum hours that employer I can work, XIJ the binary variable that changes depending on whether employers I can skills to work on activity J, TTJ the total hours that activity J needs to complete. In the case that take the binary variable broken down and replaces by the list of I and J, there will be 85 variables and 35 decisions. In the case of decision variables, will be xi, x2, x4, 3, 4, and 5. Those variables are given by this one. Thank you.
Have the mathematical model. In this case, the objective function is to minimize z, and z equals to 112x1. This is the cost per hour for the employee 1 multiplied by the total hours worked, plus 100x2 plus 43x3 plus 166x4 plus 30x5. Now, in the constraints, we can see the total hours worked by each employee has to be less or equal to the max hours each employee can work. Next one is the hours each employee worked on each activity. In this case, we can see the use of the binary variable. So the binary variable is multiplied by the hours each activity needs to be done. If the employee have the necessary ability, the binary variable will be equal to 1. If not, will be equal to 0. So by multiplying these two, if the employee can work on that ability, on that activity, the result will be equal to the hours each activity needs to be done. If not, it will be equal to 0. Finally, we have that the time worked on each activity has to be equal to the time each activity needs to be done. We can get that by the summatory of the time each employee worked on an specified.
The last thing to see will be the results of the simplex. Here we can see the C value. We can also see how many hours each employer will work and how many hours that we work on each task. We can also see that all the restrictions are satisfied and that the equalities are correct. This leads us to the analysis of the results that will be the following. Thanks to the solver using the simplex method, the following could be concluded, and the employee Cesar Estrada will work 8 hours a day. The employee Jorge Estrada will work 8 hours a day. The employee Gian Estrada will work 7 hours a day. The employee Armando Zamudio will work only 8 hours of the 12 available. The employee Iker Torres will work 9 hours a day. The breakdown of activity time is as follows. Cesar Estrada, 8 hours in general maintenance. Jorge Estrada, 5 hours in unity repairs and 3 hours in plumbing. Gian Estrada, 7 hours in construction. Armando Saucedo, 3 hours in construction and 5 hours in plumbing. Iker Torres, 5 hours in unity repair and 5 hours in material portion. The total cost of hiring employers for the necessary hours will be 3,588 per day.